What is power factor meter and where it is used to measure what electrical quantity? Exam preparation, high yield, single phase electrodynamometer type power factor meter. Master study guide, construction and working principle. In this lecture, I teach you such trick and tips to enrich yourself. To know this, you have to watch till the end of the video. The complete anatomy figure shows the details construction of dynamometer type power factor meter. As per figure, the P1 and P2 are the two fixed coils which are connected in series. The A and B are two moving coils which are rigidly connected to each other in such a way that the axes of two coils are at 90 degree to each other. A pointer is connected with this system and shows the reading over a graduated scale. The moving coil A and B are identical. These are called pressure coils or voltage coil. The current through the coils are proportional to the supply voltage. The coil A has non-inductive resistance R in series with it, while the coil B has an inductive L in series with it. To know this, you have to watch till the end of the video to enrich your excellency. System 1, the fixed coils P1 and P2 connected in series with the main circuit. They carry the main current in the circuit. If current is large, a fraction is passed through it. Magnetic field is directly proportional to main current. Wait for it and watch until the end because the points I am sharing at the finish are going to be most important. System 2, the moving coils A and B. Identical coils known as pressure or voltage coils. Current is proportional to supply voltage. Rigidly connected to each other. Crucial mechanical details. Their axes are locked exactly 90 degree apart. If you have enjoyed the video so far, please give it a like and share it as much as possible with your friends. The moving coils, a tale of two circuits, coil A and coil B. Series component for coil A, non-inductive resistance R. Series component For coil B, inductance L. Phase relationship with coil A is in phase with supply voltage, and for coil B lags voltage by 90 degree. Frequency: coil A is independent of frequency and coil B dependent on frequency. Magnetic field strength: for coil A equal and for coil B equal. Values of R and L are adjusted so both coils carry equal currents at normal frequency. Drop a comment. Let me know what kind of video you want to see in future and where you are watching from. The electrical shift. Because of R and L, we get two magnetic fields of equal strength for coil A and coil B, but with a 90-degree phase difference. As per figure, x-axis represent the time and y-axis represent the magnitude. Green color curve represents the A coil, and the voltage as current are in phase for coil A because it is resistive load, and a red color is represented for coil B. Here voltage V is lagging because it is the inductive load. If you have enjoyed it so far, wait for a moment because the next points are about to get even more important. The physics in action. Magnetic fields. As per figure, field direction due to fixed coil along x-axis. The deflection angle theta exactly equals the phase angle between the main circuit current and voltage. 1. Fixed coil creates a horizontal reference magnetic field. Point 2. Coil A and coil B creates their own magnetic fields offset by 90-degree mechanical and electrical. Point 3. Depending on the load's power factor, the resulting torque rotates the AB assembly. Point 4. The system comes to rest when deflecting torque equals 0. Please stay with me till the end of the video to know the cause and effect of this instrument. Working principle, cause and effect. Main current flows through fixed coils P1 and P2 that creates proportional primary magnetic field. Then voltage pushes current through moving coils A and B, splits into two equal fields offset by 90 degrees. Then the magnetic fields from the fixed and moving coils interact. Torque is generated, forcing the rigid AB coil assembly and the pointer to rotate. The deflecting rule. Deflection angle theta is exactly equal to the phase difference between the main current and the supply voltage. Reading the results, pointer indicate the power factor directly on the scale, also known as the Westinghouse power factor meter. Application limitation. This specific meter can only be used for balance load. Exam review. P1, P2 fixed current coils in series. A, B moving voltage coils crossed at 90 degrees. Coil A has resistance R in phase. Coil B has inductance L lags by 90 degrees. Pointer angle shows the exact phase difference, that is power factor. Use case balance load only. By watching this lecture, if you feel that I have provided any value, please subscribe my channel DCD Electrical Knowledge to get even notification of next coming video. Thank you.